What's up, everybody? Hiker Hybrid. Okay, I don't think I've ever touched base on a DIY, electrical video, mainly for the purpose because I don't want anybody to hurt themselves. I do most of my own electrical unless it's very large. Then I'll come in and get some extra hands on deck because you can't do everything yourself. So on big jobs, I get some help. Experienced electricians that know more than me that can make things go more efficiently. So besides that, if you're just growing your own meds in your house or your garage or wherever you may be doing this, you're going to want to, the very first thing that you need to work on is electrical. If it's more than one light, the first thing you need to work on is electrical. If you're running more than one light, I highly recommend that you wire and set yourself up for a 240 volt electrical panel that's going to be able to provide enough power for what you're trying to do. Otherwise, you're just going to work backwards. If you start using the wall and then you try to extension cord somewhere else, through other breakers and where in the house, eventually you're going to be doing this anyway. So you're only delaying the process and making the situation unsafe for everybody. It's more efficient to utilize and consume power on 240 because you're using both legs of 120 and 20, 120 and 120 or 240 from your main service panel. Okay, as an example, these aren't the specific numbers because each ballast has their own numbers, but hypothetically speaking, and this is a great example of how power is utilized better on 240. If you're running 1,000 watt ballast, hypothetically speaking, on 120 volts, that ballast is going to draw 10 amps. Okay, 10 amps on 120. That one wall receptacle right there has a maximum of 15. So you're already at 10. God forbid you try and plug anything else into anything that's run in tandem or in line in series with that receptacle. Typically, you're allowed to run between 5 and 8 receptacles in tandem, connected to your main service panel on one 20 amp breaker. But nobody's really ever consuming that that much power, so you can stick a laptop in each one of those tandem 5 receptacles in that room, because a room typically will have 5 receptacles going from wall to wall. They're supposed to be 6 feet apart. So each room typically has their own dedicated 20 amp breaker. But in that room you're only going to ever draw a maximum of 20 amps. So you're already tapped out at 120 volts running 10 amps on 1,000 watt ballast. If you were to run 240, you cut your amps in half because you're now utilizing both legs in your service panel. There's 2 main lines coming in. They're each 120. Together they're 240. You just cut your amps in half. Okay? And on we go. If you go up to 277 or 400, 400 volts, it's even better. So. But typically, I don't think you're going to find any kind of equipment in our industry past 277 volts. So speaking from just your common 240, which is a huge upgrade for anybody that's looking to run more than one light, do something like this here. What I'm doing here is wiring this up for my veg. I'm going to run 2 lights in veg instead of my usual is just 1. So trying to get this room more square footage. I actually need more power, so I'm hanging another lamp. So we got a lamp here, and we got a lamp here. So now I need to add more power. I can't run 120 no more. So we're going to switch everything over to 240. So let me, as far as the physical labor part of it, I'm not going to, do all that with you, but I will because it's just tedious and I can't film. That would be like an hour-long video or more. So. And I don't have anybody to actually hold this camera and shoot while I actually work with tools in my hand, so I have to explain it to you. So basically, you have to feed power to your timer, and what we have here is just your basic GE time switch. They use these for spas, pools, pumps, I don't know, ponds, things like that. You can find them in any big box home building supply store, Home Depot, Lowe's. Probably runs about 40 bucks. This is a cheap plastic one that was actually, it's kind of getting used for, I'm using it now for something else. It's just getting repurposed. So instead of going to buy a new one, I'm just going to use one that was laying around for this purpose. I'm save $40. But if you were going to go to the store and actually buy these, these are probably like $35, $40. The good ones are $60, $65. They're made by a company called Intermatic, and they're badass fucking wall switch timers. If I was to if I had to go to the store and buy a new one, I would not be buying this one. I would buy an Intermatic. It's gray metal box, okay, pretty slick. And I want to say they run probably about 65 bucks. So power coming in. This is a clamp right here, MC clamp. I mean, you could run just basic wire in here too. Not like this. It has to have the sheeting on it. I got brain fart right now. So Romex, excuse me, but Romex cannot be, let me explain some of the essentials to you before we go any further. Romex cannot be exposed. Romex is only allowed to be run in walls. Okay, Romex is a sheath wiring that protects the wire inside the walls, you know, from any abrasions or anything like that. So you cannot run Romex on the outside of the walls visually. If you accidentally hit it, nick it, you can, bad things can happen. So what you can do is basically, instead of running Romex, this is called MC, which is metal clad, and this stuff it's flexible. You can see how it kind of looks right there, and I just twisted on a spin-on connection right there. It just spins on, goes inside the box. This part here, okay, tightens down on the back end like you would see over here on this side. So just a different way of connecting the MC. These are 3/4 inch clamps, and this is a 1/2 inch spin on. Okay, so in this case, this box would already had these knockouts. These are knockouts, by the way. That's a knockout. These box already had 3/4 inch knockouts in place, so I just replaced the clamps to my purpose and wired it to this box. So what power comes in now, MC you're allowed to run in interior exposed areas. You're not supposed to be running MC on exterior exposed areas, okay? And by the way, this is not I wouldn't consider this box a heavy-duty exterior application, so I wouldn't even use this box outside. I would have bought the metal one. Okay, so knowing that I'm going to be hanging this thing on that wall is perfectly fine for my application. So power, your MC, you can be exposed, and I can just fasten that, every few feet to the wall. All right, if you're running wire that's exterior coming in from outside on a service panel, that has to be EMT. Okay, EMT is a rigid pipe, and they have insulating throat and couplings that you could add to this stuff that makes this stuff watertight. If you're coming in from outside on a service panel, it's got to be a conduit, rigid, or like EMT. Okay, then you're going to need a pipe bender and stuff like that. But we're already set up for power in here because I have a sub panel in the attic right there. So I'm just adding another 240 to my sub panel and wiring that to this, and this is going to actually time my outlets for my lights. Bringing power in, now that we understand some of just the very basics, we're going to bring power in here, and your timer part is your feed. Okay, but you're also, because we're running we're running this timer on 240. This timer can be configured, most of these, all of them I want to say, can be configured for either 120 or 240 or 277. I mean, they got all kinds of different, 277 on here. So in this case we're configuring it for 240. So the first thing that you want to do is change your dip switch right there. Okay, see, it says 1 is off, 2 and 3 are on, and 4 is off. There are also instructions for this in here. Do not fire or apply power to this before that. That is your first step. Okay, so bringing wire in here, you're going to have to feed these terminals. 120 goes here and 120 goes here. Okay, jumping that power right here, you're going to make a loop that jumps on common 1 that feeds this timer switch, this 120 timer switch, and then the red wire. These could be any color wire. I just understand that the black and red. So both of these are hot. This second leg here coming in, this is also going to be jumped from timer to COM2, which is over here. So you would have noticed both of these screws that I'm jumping is on the end of this here. So this is a power supply. Now that's supplying the timer with power. And once the timer trips, it will feed these lines here, which is, in this case it says no, and then no 2. So no, and then no 2, and no 2 go through here and to here through my MC and feed my receptacle duplex box. Okay, and these duplex boxes, I have the round one with the raised, half-inch or lip or something. These things are so brilliant. They're just amazingly handy to have. You can configure these things with switches and receptacles and do a multitude of different tasks with the electrical and your grow. In this case, I have it wired just like this because 2 ballers are going here. If I wanted to make this duplex box, I would have just 4 outlets. I would have just bought another one of these receptacles and a duplex cover with 2 receptacles, so it would be 4. In this case, I'm only wiring this with 12-2 wire, which is 2 hots and a ground. So each of these wires are hot. This black is hot, and this wire is hot because when the timer kicks these on, it kicks this on, and it kicks this on, and they engage. There's little springs in here. You guys probably don't need to know this, but just so you kind of understand how this stuff works. And then once the timer is on, it feeds power each one of those 120s down. Now notice that I'm still black over here, but right here I'm white. That's because this red wire and these black wires over here were just standard THHN wire that I had laying around, and I could have made this black wire right here a white wire so it would look cleaner, but in the end it's all the same. Just know what you're doing and understand this before you do it. And if you don't understand or you really feel uncomfortable doing any of this, please do not do this or attempt to do this. These are for the people that kind of know a little bit, but maybe they want to know a little bit more, or they're unsure, they have some basic questions. This is just that guide to help you achieve what you probably already know how to do. So basically your ground is going to be wire nutted in here. I'm not running, so here feeds the power, and this is your ground. Okay, this is going to go to, by code, everything must be grounded. So that means when it comes in this box is not metal, so I cannot ground it. That's just a given. Okay, so I'm going to wire nut it, feeding power. I'm going to wire nut this here, and this ground does come into this box also, and it's wire nutted inside. I'm grounding the box, I'm grounding the receptacle, so individually. So the receptacle and the box are grounded. So there's 3 green wires in there, wire nutted together. Okay. And then you have your black and your red going to each terminal on the receptacle. Again, 120 plus 120 equals 240, and then you have your ground. Now this box is wired for 240 and you're safe. Okay. This is a 20 amp receptacle. 20 amp, they have this cross right here. If it's a 15 amp, you'll notice right away because it'll only look like that. 20 amps is this, but this is the professional heavy duty grade, you know, whatever. It was the expensive one. So now that we understand how to hook this up, yeah, now I just got to get this on the mounted on the wall, bring the MC down from my sub panel, and I got to feed power to here. Before we tighten these down, we're going to feed power to both of these. There's an extra, see, to the left and to the left of these wires, these jump wires, there's an extra space there to feed actual power to the box, and then those jump wires distribute the panel, the power to where they need to be for the timer to function. Okay, so I hope that makes sense. Let me show you what my sub panel looks like, so I can explain a couple things on that. So this is my MC right here that I'm touching. It's very dark up here, and I have it coming in right here. You can see that the ground wire is the green wire. Always keep your grounds down into the back of the box. You can see that I got all my grounds and neutrals pushed down into the back of the box all the way around. You want nice clean work. You don't want any grounds protruding in the front to come in contact with your terminals. Now this box is live because I have equipment in my room. This is the sub panel. This is a 100 amp sub panel that feeds my entire grow. I can't shut the power off, otherwise I'm gonna have to spend hours resetting shit. So in this case, working on a live box is fine as long as you are not accident prone and do not touch any of these terminals. Okay, first step is bringing this ground in. You're gonna have to strip enough. God damn, let me try and get another light for you guys. I can't do that. Okay, so bringing your MC in, your ground, which is the green, is going to go over and all the way, for me anyway, in my sub panel, is going all the way over and connecting to my ground bar, which is right there. The neutral bar is the white one, and it's right here. They are different. In a sub panel, your ground bar, which is there, and your neutral bar are separated, which means they are not connected together because this is not a main panel. Only your main panel has your neutral bar and your ground bar tied together in the center. I'm not at my main service panel, so I can't show that to you, but basically in the main service panel they're tied together, but they are different. Okay, so that said, first thing you're going to want to do is connect your ground. Again, I'm not going to do the actual labor part, so you want to make sure you've pulled enough wire through. In this case, you can see that my breaker was a square D 20 amp breaker right here is 240, is going to go right here. So in reality, I probably only needed 6 inches on this white and this black wire to complete the connection to the breaker. But I need the green wire to go over, up, and all the way around. So in that case, I had to pull out a whole bunch of wire and unwind a whole bunch of metal clad around to get that length I needed for the ground. Okay, so connect your ground wire. The next thing you're going to do is you're going to connect your white and your black. See, white and black. It doesn't really matter in configure in which way you wire this to this, because you got to understand that both of these are 100. Each wire is 120 volts. Okay, so together 240 volts. But code, when you're just wiring this black, white, or black, red, black, red, black, red, that's typically how it goes. So and that's on your main panel. You see how I do that on my sub panel too, so I can match the load distribution between each bar 120 coming in off the main service panels. So what you're going to do is cut your wire to length, okay, your black and your red accordingly, and then you're going to connect them to each one of these wires, black, red, or black, in this case black, white, because that's what I'm feeding through this MC. You're going to connect those to the terminals, tighten those down, and just leave this breaker off. Do not connect this breaker to your service panel or your sub panel and then hook up the wires. You're going to shock your ass, okay? You connect your wires first, and then once everything's good to go, then you clip this in the off position, okay? Not the on. So that means off. Make sure, do not skip that step. When you go to throw this breaker, when you power it, you'll flip it on, and then that will power my timer in this case, or your equipment, however you choose to wire this stuff up. So there you go. Connect those wires, leave this until the rest of your work is finished. Once the rest of your work is finished, then you can come in here and pick it up, because it's already your wires will already be connected, and then you can clip it in with the power off. Okay, and once you're ready to apply power to your project, you can go ahead and push that on, okay, once everything's done. So that's it, guys. If you guys have any questions on, there's a face plate to my panel, so you know this is never exposed. It does have a plate in the front of it, okay? So basically, there's a 100 amp panel, and it's more than I need, but at the same time, if I need power, it's here. Always think about that, guys, because you might want to expand, and if you didn't do it right the first time, you're going to have to do it again and again and again. Don't backpedal and try and save $1, because in the end, you're going to end up spending $5 just because you tried to save $1. It's just do it right the first time. Get the equipment that you need, and set yourself up for success from the beginning, so you're never having to do these things over and over and over and over again. And I know I'm kind of practice what I'm preaching here for a second, because in veg, I've always, for years, I've only run one light in veg. Just recently now I just feel like I want to go two, so I'm gonna add a second receptacle and actually instead of running on 120, I'm going to run 240. So now I have a room for expansion, and if I wanted to, I can. This is only a 6-slot box, but it's wired for 100 amps. If I want to, I can actually change out this box for a box that has more slots in it. But this is all that I'll ever need. One breaker for veg, lights, AC equipment, and that's about it. That's about it, guys. Alright, if you guys got any questions, go ahead and hit me up. Don't be cheap though. Alright, set yourself up for success in the beginning. Alright, guys, I'm out of here. I'm going to finish this job because it is hot as fuck up here. I swear to God, I'm sweating bullets. Alright, peace.